Hi everybody, and welcome to Chapter 7 of AP Statistics and the wonderful world of random variables.
In this presentation we will cover many topics from two different sections.
In section 7.1 we will discuss random variables, discrete random variables, continuous random variables, as well as how to use the area under a normal curve to find probability.
In addition, we will cover the law of large numbers.
In section 7.2 we will discuss how to find the mean and variance of a random variable, the laws of mean, variance, and standard deviation, and the rules that follow those subjects.
Let's get started.
Let's get it started. Let's get it started in here. Let's get it started. Let's get it started in here. Let's get it started. Let's get it started in here. Let's get it started. Let's get it started in here.
Hey, I'm Keith and welcome to section 7.1. In this section, we will teach you the basics of random variables, in addition to discrete random variables, probability histograms, continuous random variables, and density curves. So, let's get it started. So, right now you might be asking yourself, what exactly is a random variable? A random variable is a variable taking numerical value determined by the outcome of a random phenomenon. So why do we care about this random variable? A random variable is useful to us in statistics because it allows us to show the outcome of a random event in numerical form.
Man, statistics is so fun. Go.
And here's an example. So let's say I flip 2 quarters. Instead of writing my data down as 1 heads and 1 tails, I let x represent the number of heads for each random toss. So x would be equal to 1 because I tossed 2 coins and received only 1 head. This is known as the probability distribution of a random variable. This is valuable to us because it makes finding the mean of several tossed coins much easier to calculate.
Does 1, does 2, does 3.
So let's keep moving on now to discrete random variables. A discrete random variable has a countable possible number of values. MySpace. This allows us to set a probability for each possible outcome between 0 and 1. This also means the sum of all possible outcomes are equal to 1. Therefore, the probability of an event is the sum of all of the probabilities that make up that event. So for an example, I'm going to return to my coins. Because we know that we are only tossing 2 coins, we can set the probabilities for each outcome. To find this, we must find the possible number of outcomes. The first possible outcome is x equals 0. In other words, we have 2 tails and no heads. Here we have x is equal to 1 because we have 1 head and 1 tail. And lastly, we have x equals 2 because we have 2 heads and 0 tails. X equals 0, or 2 tails, has a probability of 1/3 because it is one possible scenario out of 3 total events. X equals 1 and x equals 2 also have a probability of 1/3 because they each are one scenario out of a possible 3. So this is a demonstration of a discrete random variable because we can place a probability on each of the separate outcomes of the coins. To show discrete random variables in statistics, we most commonly use a probability histogram. To make said probability histogram, we place the possible outcomes along the x-axis, 0 through 2, and all the probabilities along the y-axis. To make a probability histogram for the coin experiment, we would use a setup exactly like this. Along the x-axis, we would have x equals 0, 0 heads, x equals 1, 1 head, and x equals 2 for 2 heads. Along the y-axis, we would have the possible probabilities only up to 0.5 because we don't need to go any higher. Earlier in the coin experiment, we determined that each of the possible outcomes had a 1/3 chance of occurring. To graph this, we would find 1/3 on the probability scale, in other words, 0.33. Then we would graph like so. All these lines are on 0.33, representing 1/3, thus showing